Bismillahirrahmanirrahim. So this is the sixth lecture of statistics and probability theory. In previous lecture, we have studied the properties of arithmetic mean. The very first property was that the sum of deviation of all the observations from their mean is equal to 0. The second property was that the sum of square deviation of each observation from its mean is always minimum. The third property was that how to calculate the combined mean if you have the means and number of observations of the subset of the sample. And the last property was the transformation property, in which we have discussed how to calculate the mean of a transformed variable, and that transformation would be a linear transformation. So quartiles. So this one is the first quartile. This is also called lower quartile, and we denote it usually with Q1, below which is 25% of the data, because as we are dividing data into 4 equal parts, so each part will have 25, 25 and 25% of data. So Q1 have below 25% of the data, and above Q1 there is 75% of the data. 25 plus 25 plus 25. So together it is 25 plus 25 plus 25, 75% of the area of the data, and this is the point below which is the 25% of the data. Q2, this one is the second quartile, and this is usually the median, also median, and Q2 give us the same values, and this is also called second quartile or middle quartile. It is denoted by Q2. The data between Q1 and Q2 is 25%, and data below Q2 means total data below Q2 is 25 plus 25. It means it's 50% of the data below Q2 and 50% of the data above Q2, because Q2 is basically a median, and median divides the data into 2 equal parts. Q3, quartile, third quartile. This is also called upper quartile, and this is the point, a cut point, above which is a 25% of area. The area between Q2 and Q3 is 25%, and total area below Q3 is 75%. 25, 25 plus 25%. And this one is the interquartile range, and this is basically Q3 minus Q1. So this is basically this area, this particular area, and this is interquartile range. Deciles, the values which divide an array into 10 equal parts. In deciles, we divide the data into 10 equal parts. Let's suppose we have the data, and we have divided it into 10 equal parts. This one is the first part, so this cut point is D1. Next one is D2, and these are the equal parts. It means the data between D1, D2 and D2, D3 all are same, as we are dividing into 10 equal parts. So the data in each part is, and the area between D2 and D3 is 10%, and this one is D4. Next one is D5 and D6, D7, D8, D9. So these are 10 equal parts. So these are 10 equal parts, and each part have 10% of the area. Here the middle point is D5, which is this point which divides the data set into two equal parts, below which is 50% of the data, above which is 50% of the data. This point is D7, and if you say that the data between D6 and D7 is 10%, but the total data below D7 is 70% and above D7 is 30%. And this one is D3. The area between the data between D2 and D3 is 10%, but total data below D3 is 30% and above D3 is 70%, and D5 is equal to median here. In this case, median is D5, whereas in the case of quartiles, Q2 is the median. Percentiles, the values which divide an array. Arrange is basically when you arrange the data in ascending or descending order. That one is called the array, and you usually do this for the ungrouped data. There is no need of array in the case of grouped data. The values which divide an array into 100 equal parts are called percentiles. So if this is the data, let's suppose this is the data and you divide it. This one is the first part and this one is P1, below which is 1% of the area, as you are dividing into 100 equal parts. Next one is P2, and again 1% of the area. And the last one will be P99, as we are dividing into 100 equal parts, and above which also is 1% of the area. So the median here will be P50, that is below which is 50% of the area, and above that point will be the 50% of the area. If you say that this point is P99, total data below P99 is 99% and above P99 is 1%. If you concentrate on P2, the total data below P2 is 20% and total data above P2 is 80%. So this is the way to look into the quantiles, that what are they basically representing. So how to calculate quartiles for grouped and ungrouped data? So there are two cases. The first one is if j into n by 4 is an is not an integer. What is the integer? Integer is basically a whole number, and this j represents the jth quartile. J is basically equal to 1, 2, and 3. When you substitute 1, it means that is you are going to calculate the first quartile. When you substitute 2, that means you are going to calculate the second quartile. And when you substitute j is equal to 3, that means that you are going to calculate the third quartile. So let's suppose we have the data 3, 4, and let's say 6, and let's say 10. Let's suppose these are the marks of the students. 1, 2, 3, 4, 5. So n is equal to 5. Now, let's suppose you want to calculate the first quartile. So substitute j is equal to 1. So what will you get? Q1. For this purpose, first you have to find j into n by 4. It means 1 into 5 divided by 4. And 5 by 4 will be 1.25. So basically this is not an integer. And now what is the first quartile? Observation with ordinal number j into n divided by 4. This bracket represents that you need to take the first very closest integer to these values in this particular place. Now what you need, the very first thing you have to do that arrange this data set in ascending or descending order. As we already have this data set in ascending order, 3, 4, 6, 10, 12, I already wrote in the form in the arranged form. But if your data is not arranged in any order, whether ascending or descending, so first make the array out of that data, that is arrange that data into ascending or descending order. So now here we already have the arranged data, so we will calculate the quartile, and this one is the first quartile. So we substitute Q1 observation, whole this thing will be the same, of with ordinal number 1.25 plus 1. It means that the very close integer is 1, because this is 1.25. So it means we will take 1 here plus 1. That will give us 2. It means Q1 will be equal to the observation with ordinal number 2. So if you go through this data and you start counting here, this is 1 and this is 2. So Q1 will be equal to 2. So this is the first quartile. Now if you want to find the second quartile, so what will you do? For the sake of the second quartile, you have to substitute 2 in place of j. Then what will you do? Now, just substitute j is equal to 2 in place of j, and this is the first place, and this one will be 2. And let me take the same data as I have taken before. It was 3. I think this one is 4 and 6. maybe some value may be changed, but they are 5 observations as I remember, and 11, 1 2 3 4 5. So I think here that there was 12. Okay, now n is 5 divided by 4. So what will be the answer? This is 2.5. So again, this is not an integer. So what we will do, we will use this thing to find out the second quartile. So what you have to find? You have to find Q2, and that one is equal to observation with ordinal number 2 into 5 by 4, which is 2.5. Plus 1. And now the very close integer is, I will take here 2, and 2 plus 1, which is equal to 3. So Q2 is equal to observation with ordinal number 3. So as this is already arranged, so 1, 2, 3. So this one is Q2. And as we already know that Q2 is median, so you all know how to find out the median in ungrouped data. And if you find out in this way, so this is the value of the median. If you go to the lecture in which we have discussed how to find out the median for ungrouped data, you use the same criteria as we used in that lecture. You will get the same value as we have got here in process to find out the Q2, which is 6. So Q2 is equal to 6, which is equal to median. You can use the formula of median also. The results will be same. And for the purpose to find out Q3, what you will do, you will substitute J is equal to 3. So that would be J3 into N, which is 5. So 3 into 5 divided by 4 is 3.75, and Q3 is equal to 3.75. So we will take here 3 plus 1. So Q3 is equal to observation with ordinal number 3 plus 1, which is equal to 4. And if you go through this data, so 1, 2, 3, 4. So this is the point, which is Q3. So Q3 is equal to 10. So this is the way to find out the first, second and third quartile in case when the j into n by 4 is not an integer. So what will happen if j into n by 4 is an integer? Let me consider some data. So now to find out the quartiles for ungrouped data, in case when j into n by 4 is an integer, let me suppose that there are the marks of some students 32, 12, 15, 22, 19, 20, 27 and 30. So these are total 8 observations. So whenever you are going to find out the quartiles, deciles or percentiles or median in case of ungrouped data, the very first step you should take is to arrange the data in ascending or descending order. So I have arranged the data in ascending order. Now I'm going to find out the first quartile, for which purpose I have to substitute Q j is equal to 1 in place of j. So this one is 1. and n are total 8 observations divided by 4, which is equal to 2. So this is an integer, so the first quartile will be Q1 is equal to average of 2 observations with ordinal numbers j into n by 4 and j into n by 4 plus 1. So this would be equal to 1 into 8 by 4 and 1 into 8 divided by 4 plus 1. So this would be the average of 2 observations with ordinal numbers 8 by 4 and 8 by 4 plus 1. So this would be 2 and 2 plus 1, which is equal to 3. So Q1 will be average of 2 observations with ordinal number j into n by 4 and j into n by 4 plus 1. It means Q1 is equal to average of 2 observations with ordinal numbers 2 and 3. So you will go to the arranged data. So 1, 2 and 3. So this is the observation with ordinal number 2 and this is the observation with ordinal number 3. So Q1 will be average of these two observations, which is 15 plus 19 divided by 2 this one is equal to 17. So Q1 is equal to 17. Similarly, you can find out Q2 and Q3 as well. Deciles for ungrouped data when j is equal to n by 10 is not an integer. What the thing is change when j into n by 10 is not an integer. So if you focus here, what the thing is change in the case of quartile, this j into n was divided by 4 and here we have 4 in the divisor. In case of deciles, we have deciles for ungrouped data. In the case of quartile, we are dividing the data sets into 4 equal parts, but in the case of decile, we are dividing the data into 10 equal parts. So what's the difference? You can see here that here we have 10 in the divisor and here as well. Rest of the procedure is same as we have used in the case of quartiles. In the case of quartile, only we have here 4. And whenever you have to find out the quartile, what you do, j into n by 4, whether it is, you calculate j into n by 4, whether it is an integer or not an integer. Rest of the criteria will depend on this, that it is integer or not. In case of decile, you will see that j into n by 10 is an integer or not an integer. If it is not an integer, you will use this criteria to find out the jth decile. That is, if you want to find out the 8th decile, you will substitute 8 in place of j. And if you want to find out the 5th decile, you will substitute 5 in place of j. Similarly, if j into n by 10 is an integer, you will use the same criteria as you have used in the case of quartile, but you will use here 10 in divisor and here as well. And now you have j is equal to 1 to 9 of the options. That is, you can find out D1, D2, D3, D4, D5, D6, D7, D8 and D9. So this is the way to calculate the deciles, which we already used in the case of quartile. Similarly, with the case of percentile, here if you concentrate here, we have 100 in place of 10. Why? Because you are calculating the percentile, and in percentile you are dividing the data into 100 equal parts. Rest of the criteria is the same as we have discussed in the case of quartiles, but j is equal to 1 to 99. Why? Because we are dividing the data sets into 100 equal parts. So these are the ways to calculate the quartiles, deciles, and percentiles. Together they are called quantiles, and we have discussed the calculation method for the ungrouped data. So that's all for this lecture.